Welcome, Hornets. This is part two of the review of chapter one, where we are looking at questions numbers 9 through 12 from the worksheet that was given. Number 9 is working with asking you to find the domain of a square root function. Just like the logarithmic functions that we saw in the previous example, we're now asking ourselves, what's going on when we see this radical? Notice that a radical has two possibilities. It's going to start from a specific point and move to the right, or start at a specific point and move to the left. Each of these represents either the positive or the negative of that radical. Now, what tells me whether I've got this positive or negative is this minus right here. When x is minus, we are looking at this situation. And when there is a sum between them, or when the x is positive, we end up having this situation. So what we're going to do is we're going to say that 3 minus 5x is greater than or equal to 0. Because no matter what, when we take a radical, it has to be positive. So if I solve for this, I'm going to subtract 3. The inequality stays the same. The inequality is going to change when I divide by that negative number. So we have x is now less than or equal to 3/5. This gives me the graph starting at 3/5 and moving in this direction. Notice the domain, all values of x greater than or equal to 3/5, which is very different from having an asymptote. When we have an asymptote, we cannot say or equal to. We're now going to put this into my domain statement as a function or as a interval notation. And you'll notice I go to negative infinity. Just like infinity, we can never reach it except abstractly. So only when we conceive mathematically of where we're approaching will we know. In this case, we are approaching negative infinity, going infinitely down. Question number 10 is now working with the difference quotient. Now, it is important that you are able to do the difference quotient because that is one of our main devices that we will be working with all year long. The difference quotient is defined as f of x plus delta x minus f of x all over delta x. And we're going to be working with the function f of x equals 3x squared minus 1. Now, we've seen this before, but it's important that you keep practicing. Take any quadratic equation and plug it into this function. Okay? Next week, we're going to be working with this function, but taking limits. So the first thing I want to do is recognize if I have f of x here, I need to find f of x plus delta x. Now, some individuals have said, Mr. Lamb, I don't like delta x. If you do not want to use delta x, you must state, let delta x equal h. This will allow you to work with x plus h. Many people find that easier. It's up to you. Now, once you've done that, I'm going to put the 3 parentheses squared minus 1 and then put my x plus delta x in. Now, what you'll notice is this is a quadratic. You're never going to have anything beyond a cubic, so please don't stress. We're now going to FOIL this out and then distribute the 3 and subtract the 1. So taking it one step at a time, x squared plus 2x delta x plus delta x, the quantity squared. We're going to distribute the 3 so that we have 3x squared plus 6x delta x plus 3 delta x squared minus 1. We can now put this together into the difference quotient. We know what f of x plus delta x is. We can clearly see what f of x is over here, and we're going to put them together. So we make our fraction. I recommend that you use brackets. 3x squared plus 6x delta x. Now, as you get the practice, you won't need them, but until you get good at it and you can see it clearly, Make sure you use the brackets to avoid losing the negatives. My most pressing concern is that people forget to distribute this negative to this -1. Now, what it does when we distribute is it gives me opposites that will cancel every term that doesn't have a delta x. If you have a term that has a delta, does not have a delta x in it, you've made an error and you need to go back over it again. Our last step is to factor out the delta x that is shared between all the pieces that are left. We then simplify by reduction, and we are left with 6x plus 3 delta x. It is your responsibility to practice that and to be able to do it without any problems. The 11th question of this worksheet was now looking at a piecewise function. We are being asked to identify a specific value, x squared plus 3 for all x less than 1, and we have 4x minus 1 for all x greater than or equal to 1. Now, if they ask you to find something specific, in this case, I asked you to find f of -1. You must locate the domain. Notice that the domain that I am using is the x values less than 1. So using this function, I plug in -1, and my answer is 4. If I were asking you to find f of 3, f of 3 is greater than 1, therefore fits on this, and I'm looking at 12 minus 1 is 11. I could ask you to find f of 1. F of 1 is the change in the domain. And so you're looking at where is the or equal to. This one has the or equal to. Plugging in the 1, I get 3. So always look for what value are you trying to evaluate. That's the x. Look for the domain. Once you find where that x is contained in, plug it into that function or expression of that function and find your output. The last question we have, I'm going to be doing by hand. All right, but, and then I'll do it, let's do it first by hand, and then we will do it by the graphing calculator. Now, obviously, the graphing calculator is faster. If I just put this into the graphing calculator and hit graph, I'm looking for the 0. So I'm asking myself, where do I get the x-intercept? When you're doing it by hand, you have to get the common denominator. This is a rational function after all. It has two asymptotes, potentially a hole in the graph, and that's what we have to find. So I'm looking at x plus 1, x minus 2. Notice I get 2x minus 1. This is now my f of x. I have two asymptotes at x equals 2 and x equals -1. My 0 comes from the numerator, and I set 2x minus 1 equal to 0, and I solve. I find that my 0 is located at 1/2. Now, if we're just working with our graphing calculator, you're going to want to put in the equation into the graphing calculator. So I'm looking at 1 divided by x minus 2 plus 1 divided by, and I have x plus 1. You can't see that. Well, let me go back to y equals and try this again. Here we go. 1 divided by, notice the parentheses around the x plus 2, plus 1 divided by, parentheses around the x plus 1. Now when I do zoom 6, I should see the reciprocal function, which I do, and you'll notice that cubic in the middle. Be aware this is a classic rational function, and we are trying to find this x-intercept right here. So we're going to go through second trace. 0 is what we are looking for. And we need to be able to go to the above it so that the 0 is in between. So it's got to be in between. So above and to the right or to the left, and below and to the right. Hit enter, then move below and to the right, hit enter, followed by enter. You'll notice our solution is 0.5 or 1/2. Thank you, Hornets. This is the end of the first 12 questions. In part 3, I will be going over the open-ended FRQ. Thank you very much, and take care.